So we're talking about ordinary fractions. If you're given, let's say, example, please don't write anything, okay?
Okay.
Don't write anything. So talking about fractions, ordinary fractions, the example we have here, maybe you have something like 1 over 2 and 1 over 5. Since the numerators are both 1, it means 1 is being divided into two places, and 1 again is being divided into 5 places. So the one with the higher denominator is a smaller fraction. Okay?
Okay.
Then the one with the smaller denominator is the bigger fraction because the numbers at the top are the same. Okay?
Okay, sir.
Because the numerators are what? The same. Numerators are same. So whenever the numerator is the same, the one with the higher, are you there? Are you there? Can you hear me?
Yes, sir.
I want you to concentrate. So the one with the higher denominator is the smaller fraction, while the one with the bigger denominator. And how do we go about that? Let's say this is 1 and this is also 1, okay? In the first case, I am dividing 1 into 2, okay? Can you hear me?
Yes, sir.
Okay, good. So in the first case, I said I want to divide 1 into two portions. So dividing 1 maybe into two equal portions like this. Then the other one, I'm dividing it into 5 portions. Maybe I'm trying to say I can find a way to make 5 portions that are equal, okay? So if this is the first portion, maybe the second portion somewhere here. Okay, let me close it a little bit. And let's say the third portion is somewhere here. And probably the fourth portion is somewhere here. Okay.
Yes, sir.
Now, even if this is not, like equal, like accurately equal, what I'm trying to show us here is that, or what I'm trying to show you here is that each portion of this is smaller than one portion of this. Okay, is that clear?
Yes, sir.
Each portion of the one that have 5 portions, so each portion is smaller than the one that have 2 portions. So what you can see here is that this 1/2 is greater than the 1/5. So this represents 1 into 5 places, while this represents 1 into 2 places. Is that clear?
Yes, sir.
Okay, good. Let us look at another example. Example 2. Example 2. Let's say we have another fraction like 3 over 8 and 3 over 15. So which one is the bigger fraction?
Mm, 3/8.
Yeah, because it's the one with the smaller denominator. So 3 over 8 is bigger than 3 over 15. Or we can say 3 over 15 is less than, okay, 3 over 8. Is that clear?
Yes, sir.
Okay, good. Let's look at example 3. The third example, let's assume we have a fraction like 5 over 8 and 3 over 8. This time around, this time around, we have the same denominators. If you remember in the first case, we have the same what? numerators. Okay,
Yes, sir.
good. But in this case, we have the same denominators but different numerators. So once the denominators are the same, it means I am dividing 5 items among 8 people. Okay, and I'm also dividing 3 items among another 8 people. So which group of people will have more? Is it the first group or the second group? You know, maybe there are 5 loaves of bread, okay? 5 loaves of bread, right?
Yes.
And you want to share it with 8 group of students. So you pack them to one side, 8 students share 5 loaves of bread. Then there are another 8 groups of students, right?
Mm-hmm.
You now give that group 3 loaves of bread. So group A and group B, which one of them will each person have enough bread?
Group A.
Group A. So that means once the denominator is the same, we consider the bigger number above as the bigger fraction. Okay. So that means 5 over 8 is greater than 3 over 8. Or 3 over 8 is less than 5 over 8. Is that clear?
Yes, sir.
Good. Let's look at
One.
number 4, the fourth example. Let's look at this. Let's say we have something like, um, let's say 12 over 15, and we also have 25 over 15. Okay? Can can you hear me now?
Yes, sir.
Now 12 over 15
Sorry, sir,
and
we are about going out, but she's still with you.
no problem, man.
All
So
right, sir.
so
My book was also.
so
No,
12 over 15. Can you hear me now?
yes, sir.
Yeah, 12 over 15 and 25 over 15.
Yes, sir.
Yeah. So which one do you think is the bigger fraction or which one is the smaller fraction?
Uh, I'm coming.
Okay, you are not in the room. That's all right. Let me just keep explaining it while you get yourself settled down, okay?
Yes, sir.
All right. So it's like you want to share 12 items among 15 people, and you want to share 25 items among another 15 people. So definitely, the group of 15 that are sharing 25 will have more. Yes or no?
Yes.
Good. So we can say 12 over 15 is smaller than 25 over 15. Is that clear?
Yes, sir.
Okay, now this is the second situation. The first situation, we said the same numerator and different denominator. You consider the bigger denominator as the smaller fraction. The smaller denominator as the bigger fraction. Is that clear?
Yes, sir.
But for the second situation, if
Mommy,
we
your
have,
waters.
okay, look here. For the second situation, if you have the same denominators, so you're going to compare the numerators. The biggest numerator is the bigger fraction. And you understand why that is so, right?
Yes, sir.
Good, good,
Yes,
good.
Tó bá pè mí fún ọtí ẹ̀
So now, um, let's go to the third category. The third category, like number 5 now. Okay. So for number 5, let's assume you have something like 2 over 7 and 7 over 11. Okay.
yes, sir.
Or maybe not 7, I can use 3 over 11. or 3 over 7. Okay, I don't want to use them. So 3 over 10, I think this is perfect. Now, 2 over 7 and 3 over 10. Can you see this?
Yes, sir.
The numerators are different and the denominators are also different. So what we need to do is to make them have a common denominator. To have what?
What you can say?
Common denominator. Okay?
Yeah.
We make them to have what? Common denominator. Say that.
Denominator.
Yeah, common denominator. Say it again.
Common denominator. It's 10.
It's 10. Good. But can 7 divide 10? Can you hear me?
Yes.
Can 7 divide 10 perfectly without any remainder? Can 7 divide 10 perfectly without any remainder? Kirby?
What?
Can 7, we said there is 7, there is 10, and 10 is the bigger number. So can 7 divide 10 without a remainder? No.
Yes.
7 cannot divide 10 without a remainder. If you use 7 to divide 10, you're going to have remainder 3, okay? Is that clear?
Yes, sir.
Good. You're going to have remainder 3. So with that, let's go for the next multiple of 10. 20. 7 will not divide 20. The next one is 30. 7 will not divide 30. 40, 50, 60. It's only 70 that 7 will divide. So what we have to do is to say the common denominator is going to be 70. Okay? Are you hearing me? So the common
Mm,
denominator is going to be what? 70. So how many 7 is in 70? That is 10. Then 10 times 2 is 20. Okay?
yes, sir.
Then the other one, how many 10 is in 70? That is 7. Then 7 times 3 is what?
7 times 3
21, rather.
is 21.
21. So which one is the biggest here now? 20 or 21?
21.
Good. That means the biggest fraction is the 3 over 10. Okay?
Yes, sir.
So we can say 2 over 7 is less than 3 over 10. Is that clear? Is that clear to you?
Yes, sir.
Good. Then number 6. Let's try one more. I know you're on the road. You can't write this down. So I'm going to send all of these notes to you so that when you calm down, you can write them. Is that clear?
Yes, sir.
Now, for number 6, let's say we have something like 12 over 17 and let's say 4 over 5. Okay?
Okay, sir.
Now, if we want to compare this, we need the same denominator for it. So, to get the same denominator, it's more or less like saying 17 times 5 because 17 is a prime number, so nothing is common between 17 and 5. So 17 times 5 is going to give me 85, okay? Then 17 in 85 is 5. So 5 times 12 is 60. Then 5 in 85 is 17. 17 times 4 is 68. Okay? Is that clear?
Yes, sir.
Good. Then we can say 60 is smaller than 68. That means 12 over 17 is less than 4 over 5. Is this clear to you? Is this clear to you?
Yes, sir.
Good. Let's look at two more examples. Example 7. Let's say we have a fraction like 1 over 3 and let's say we have 5 over 9, okay? Or 4 over 9. 1 over 3 and 4 over 9. We want to check the bigger one. Now, we need a common denominator. Is that clear?
Yes, sir.
Now, these 3, can 3 divide 9 perfectly? The answer is yes. Then 9 is our common denominator. The previous ones that we have been doing, we observed that 7 cannot divide 10 perfectly. That's why we could not pick 10 as our common denominator. Because 7 is not a factor of 10, and 10 is not a multiple of 7. But in this case that we have in number 7, if you can see it, 3 is a factor of 9. Then 9 is a multiple of 3. Is that correct?
Yes, sir.
Good. So that's why we can pick 9. So how many 3 is in 9? That's 3. Then 3 times 1, 3. Then how many 9 is in 9? That's 1. Then 1 times 4, that's 4. So which one is the biggest? 4 over 9 is the biggest. Is that clear? Is that clear to you?
Yes, sir.
So 1 over 3 is less than 4 over 9, or we say 4 over 9 is greater than 1 over 3. Then number 8, let's check something like 2 over 5 and 18 over, or let's say 12 over 30, okay? Can you hear me?
Yes, sir.
So if we want a common denominator for them, you can see that 5 is a factor of 30 and 30 is a multiple of 5. So we pick 30 as a common denominator. Then we have 5. How many 5 is in 30? That's 6. 6 times 2 gives me what? 12, right?
Yes, sir.
How many 30 is in 30? That's 1. 1 times 12 gives me what? 12. So is anyone greater among the two fractions? Is anyone greater among the two fractions, Fikayomi?
No.
No, because the word give me 12. So definitely, I would say 2 over 5 is the same thing, is equal to 12 over 30. And it makes sense if I cut 12 over 30 down. I can divide by 6 here, 2, 6 here, 5. Then I have 2 over 5. Is that clear?
Yes, sir.
So 2 over 5 is the same as what? 12 over 10. Okay, okay. Um, you can take any classwork now since you're on the road, but I'm going to write a question, then you are the one that will do it for me, okay?
Okay.
So number 9, you will just look at it and reason it in your head and try to say something. And if you're wrong, I'm going to correct you. So number 9 says, let's say 14 over 20 and 12 over 18. Okay, we want to check which one is the biggest, okay?
Yes, sir.
Okay. The main thing that we have here is that this is 20, it's not a multiple of 18, and this is 18, it's not a factor of 20. So, which number do you think, which multiple of 20 do you think 18 can also divide? Let's go for 40. 18 won't divide 40 perfectly well, okay?
Yes, sir.
Let's go for 60. 60 divided by 18 will still give us decimal remainder. Let's go for 80. Divided by 18 is still going to have a remainder. If we go for 100 divided by 18, that is still going to leave us with a remainder. What about 120? If we divide it by 18, it leaves, okay, it has, oh, yeah, 120 divided by 18, it has remainder too. Is that clear? So that means the number that we can pick is like saying maybe um, 20 times 18 or half of such number. Because if I say 20 times 18, that is going to be 360. But if we try half of 360, which is 180. So 180 is divisible by 18 and it's divisible by 20. Is that clear? You are muted. I can't hear you.
Yes,
Okay.
sir.
Okay, fine. So we can use 180. Okay.
Yes,
Now,
sir.
how many 20 is in 180? That is 9 because 2 times 9 is 18. So 9 times 14 gives us what? That is 9 times 14 gives 126. Okay?
Okay, sir.
So I have 126 here. Then how many 18 is in 180? That's 10. 10 times 12 gives 120. So which of the fraction is the biggest fraction now? Is it 14 over 20 or 12 over 18?
14/20.
Good. 14 over 20 is bigger than 12 over 18 since we have seen that this one gives me 126 and the other one gives me 120 when we converted them to have the same denominator. So is that clear to you, Fikayo?
Yes, sir.